Hello class. Welcome to this quick lesson where I work the 8.2 practice problems, or 8.3. This is for the t-test. If you had trouble with the assignment, then go ahead and follow through the video, kind of follow along as I go through the problems. So the first one is the Metropolitan Bus Company claims that the mean waiting time for a bus during rush hour is less than 15 minutes. A random sample of 20 waiting times has a mean of 3.7 minutes with a standard deviation of 2.1 minutes. At the 1% significance level, test the bus company's claim. Assume the distribution is normal. So they claim that the mean waiting time is less than 5 minutes. So the claim is that the mu is less than 5, right, for 5 minutes. So now this is actually a statement of inequality, so that means that it belongs to the alternative hypothesis, right? HA or H1. So that belongs here. So now, because we have this, now we can flip it or do the opposite or the complement to get the null hypothesis. Okay, so those are our hypothesis statements. So here we're going to choose an item. We're going to choose the greater than or equal to symbol, and then we're going to type in 5. All right, and there's our null hypothesis. Then we're going to, for this one, you're going to type in, or you're going to click the drop down for less than, and then type in 5. All right, so there's my hypothesis statement so far. Then step 2, remember for the t-test, step 2 is to figure out what your alpha is. So here the alpha is 1%, 1% significance level, so it's 0.01. That's given right there, right here. Okay, so the now it says that you took a sample of 20 waiting times, so that means our n here is 20, and they said that the sample of the 20 waiting times has a mean, so that's a sample mean, that's your average. Your sample average, which is 3.7 minutes, and the standard deviation, which is from the sample, so that's the sample standard deviation, S, that's not your sigma, that's your S, is 2.1. All right, so we got our information. Step 3, test direction. So because it's pointing to the left for the alternative hypothesis, that means it's a left-tailed test, okay? All right. Now for the degrees of freedom, remember that we need to calculate the degrees of freedom. Well, we know that n is 20, so it's very simple. You just do df is 20 minus 1, which is 19. So you're simply going to type in 19 there, and that's my degree of freedom. Alpha, we said, was 0.01. All right, so for my critical value, so now remember, we're going to need our degree of freedom. We're going to need the type of test, which is a, we said it was a left-tailed test. So we're going to need that. And we're going to need the significance level alpha. So we're going to need those 3 things for the t-chart. So we're going to go ahead and pull the t-chart up so that we can look at it. All right, so let's go ahead and look it up here. So I went ahead and included it on the slide here. So we got a the df is 19, the alpha is 0.01, and it's a one-tailed test. This is only on the left side, so we're going to use one tail. So if you zoom in on this, we're considering one tail, 0.01, and a df of 19, which is over here. So that means if I figure out where they intersect, it's going to be over here at 2.539. Okay, so that's my critical value here. So we're saying TC is 2.539. Now remember, this is a left-tailed test, right? So since it's a left-tailed test, this is actually a negative number. Remember that if you draw the curve, right, the T curve, which looks like the Z curve, but it's flatter. You start at 0, -1, -2, -3. And remember, since it's a left-tailed test, we're over here, we have to be negative. We can't be positive, right? And we're shading on the left side. Okay, so my critical value is negative, my rejection region is on the left. All right, so we got negative 2.539. Then you go ahead and attach a picture of your sketch, which I did my little sketch here, marking your critical value and shading the rejection region. All right, now we're going to calculate the t-test. So the t-test, remember that the formula is very similar to the z-test formula. So it's x bar minus mu divided by s instead of sigma, right? We use s instead of sigma there. And the x bar, we said earlier that the x bar is 3.7, and the mu is from the hypothesis, so it's 5, right? So 3.7 minus 5 divided by 2.1 over the square root of 20. Okay. So 3.7 minus 5 over 2.1 over the square root of 20 people in our study. So we'll go ahead and calculate that. You just do it on the calculator. Any calculator will do. If you're having trouble with this, with typing it in on the calculator, I will highly suggest doing it on Desmos. So I'll go ahead and show you that right now, actually. So let's go ahead and show you on so if you type in desmos.com or Desmos graphing calculator, or no, Desmos scientific calculator. So quick little tip here, just in case you need it. It's probably the most useful scientific calculator out there on the web because it gives you the input exactly as you see it. So if we're typing in, we were typing in what, so we're going to do a fraction, 3.7 minus 5, and then go down to the bottom, 2.1 divided by square root, there's a square root button here, and then square root of 20. You see, it tells you, it looks exactly how you write it. So it appears like that. That way you know if you're confident in your result. So I really like Desmos calculator. It's really awesome. So now we're going to go ahead and round this. So negative 2.77. Okay, so we're going to bump it up. So negative 2.77 is my t-test. So if we label that on our graph, well then clearly we're right here. So that means we're in our red region. Red means rejection. So we're in our rejection region here. So that means we're going to reject the null hypothesis. So here I'm going to go ahead and click that. I'm going to replace that with, I'm going to show my calculations here, right? So I'm going to show, okay, well I have, deleting the underscores and all that stuff. 3.7 minus 5 divided by, get rid of all of that, 2.1 divided by square root of 20, and then that's showing my work. And then, okay, I'm going to go ahead and type in the final answer, negative 2.77. All right, so that's how showing your calculations. I try to provide a template for you. Okay, so then the decision, we said we're going to reject the null hypothesis. And then the conclusion, so if we reject, that means that there is enough evidence to overturn it, right? So there is enough evidence at the 1% level of significance, all right, remember earlier that we said the claim belongs to our alternative, right? So that means we're going to use the word support here instead of reject. So there's enough evidence at the 1% level to support the claim that, and then you're going to type in the claim here. You're going to just type it in. What was the claim? Well, the claim was that the mean waiting time for a bus during rush hour is less than 5 minutes. That the mean waiting time for buses during rush hour is less than 5 minutes. All right, and then there's your concluding statement. All right, let's look at the next one. So we have a local group claims that the police issue more than 60 speeding tickets a day in their area. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. At the 1% significance level, test the group's claim. Okay, guys, so went ahead and there was an error with that problem. It didn't actually provide you with the data that the police randomly selected from the 2 weeks. So I went ahead and included the data. So it says that the police randomly select 2 weeks. Their research, which is given below, yields the number of tickets issued for each day. At the 1% significance level, test the group's claim. So according to this problem, the claim by the police is that they issue more than 60 speeding tickets. So that means that the average number of speeding tickets is greater than 60. Now that's a statement of inequality. So that actually belongs to the HA or H1. So that means that belongs here. And then you're going to flip it and do the opposite. All right. And so that's going to be our hypothesis statements. Now, because this is pointing to the right, that means if this is pointing to the right, it's going to be a right-tailed test. Okay, so it's going to be a right-tailed test. And let's see here. What else do they tell us? They tell us our alpha, which is at the 1% significance level. It says they randomly select 2 weeks. So my N is actually going to be 14. 2 weeks is 14 days. So and we're dealing with days here. Okay, so 14 days. And so my degree of freedom is 14 minus 1, which is 13. All right, so we got the hypothesis statements. I'm not gonna type it in here. You know how to do it now based on the first problem. That's my alpha, my test direction, my DF. Now let's find our critical value. So 13.01. And then because it is actually a right tail test, that means we're going to use a one tail, right? So 0.01, one tail, and then 13. So let's go back to our chart here. So one tail, 0.01, and then instead of 19, we're going to go to 13. And since it is a right tail test, that means it's going to be positive, okay? So is going to be positive 2.650. So let's go back to our original right here. So our T critical is positive 2.6. I believe we said 2.650. Yep. So 2.650. And then we're going to draw our graph. .650 is around here. That's our T critical. We are dealing with a right tail test, so we're going to shade the right region. All right, so that's my sketch of the T distribution. And then to calculate our T test, we're going to need our X bar and all that stuff. So according to the original problem, it says that, well, we need to figure out the X bar, right? We need to figure out the X bar from this data. We also need to figure out the standard deviation from this data because they don't give that to us, right? So we're going to have to calculate those two numbers. But we do know that the mu is 60. 60 speeding tickets was their claim. And we do know the N, which is 14. So based off of this data, we're going to have to actually calculate the X bars and all that stuff. So that's going to take a little bit of work. So let's do that down here. So for the X bar, that's simply the average of the data that they provide to you, right? So we got to do 70 plus 48 plus 41, dot, 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 all the way to 58, the last number that you see there, and then divide by 14 days. Okay, that'll provide you with your X bar. All right, so we're going to quickly Actually, we're going to quickly do that. So if you add those numbers, you get 843, and then 843 divided by 14, it's going to give you about 60.21. So we'll round it to 60 point. Actually, we'll leave it at 60.21. That'll be fine. So we got our x bar. Now what we need to do is calculate our s. So how do we calculate our s? Well, to calculate our s, this is a formula that we used way back in the beginning of the year, right? Probably second quarter, I would say. But we're going to need that formula here. So the formula is the square root, and then you're going to add up some stuff. What are you going to add up? You're going to add up the data minus the mean that you just calculated and then square it. Then you're going to divide by however many tickets were issued minus 1. Okay, so again, what does this mean? Well, this means that you're going to take the square root. Now, the first data point, that's x. The first data point is 70 right here. So 70 is going to be my first x value. So I got here 70 minus, what's my x bar? Well, we just calculated right here, 60.21. 60.21 squared. All right, and then we're going to add that. We're going to continue elongate this standard deviation bar plus parentheses. Now, what's your next x value? My next x value is 48. So 48 minus, and then what's x bar? Well, that's 60.21 squared. So you can see this is going to take a while, right? You gotta do all of this to get the standard deviation plus dot dot dot, and then we'll end it. So when you show your work this way, plus dot dot dot, and then use your last x value, which is 58 minus 60.21 squared. That way you're not writing a whole bunch of stuff. All right, so that's that, and then I gotta divide that whole thing by 20 minus 1. Or not 20 minus 1, it's 14 tickets were issued. So 14 minus 1. Okay, again, it's simple to do this if you have Desmos. So I would suggest, doing it on Desmos or doing it on any calculator. A lot of calculators will do this stuff for you as well. So we're going to do the square root. We got a fraction, so you could do a fraction bar right here. All right, I'm going to do parentheses, 70 minus I forgot what my x bar is. My x bar is 60.21. Oops. Parentheses squared. There's a square button right here. You're going to arrow out of that, plus, and then parentheses, 48 minus 60.21 squared, and so on. And then we'll go ahead and continue this to get the calculation. All right, so I went ahead and did the calculation. I finished off the rest of the numbers. I typed in all of the numbers in the numerator, right? And then I typed in the denominator. The denominator shows up right here. And I get about 13.43. 13.43. So that's going to be our standard deviation. That's going to be S. So S is approximately 13.43. All right, so now we got our S. We got our X bar. So we got X bar, we got S, we know N is 14. We're able to calculate the t-test. Okay, so let's go ahead and do the formula now that we're ready. X bar minus mu was 60, that was our claim. S divided by square root of N, which is 14 tickets, and then we're going to go ahead and calculate that. So you can see this problem takes a lot longer when they're not giving you the data, the standard deviation and stuff. But sometimes that'll happen, especially if you're actually doing this on your own. You're going to have to actually calculate it. All right. right? So went ahead and calculated the t-test. So that's going to be 0.06. If you round that to the nearest, second decimal place, the nearest hundredth there, you get 0.06. So that's our t-test. So now if we label that, that's actually close to 0, right? So 0.06 is actually over here, and that means it's not statistically significant. So what I mean by that is that the 60.21 is not significant enough to say that we have enough evidence, right? So if it was like 62, 63, 65, then maybe we have enough evidence to reject here. But since it's 60.21, it's so close to 60. This is why we're outside a rejection region. It's not statistically significant, is what we say. So we reject, and there's not enough evidence. Okay, so we're gonna say that we reject here. Our decision here is to fail to reject. I'm sorry, I said reject. Fail to reject because we don't have enough evidence because it's outside of the rejection region here. So that means we do not have enough evidence. There is not enough evidence at the 1% level to, now the claim belongs to our HA. So we're going to use the word support. Otherwise, we would use the word reject. So there is not enough evidence to support the claim. Let me go back here. There is not enough evidence to support the claim that, and then this is where you type in the claim, so that the mean number of, let's see, the mean number of tickets, I think it said. Yeah, that the police issue more than 60 speeding tickets a day. So this does not mean that they don't issue more than 60 speeding tickets a day. This just means that we don't have enough evidence to actually support that claim. So it was ambiguous. Of course, we would have to maybe change our level of significance, or we would have to actually collect more data probably to actually see if this is true or not, right? So basically, not enough evidence, so we'll have to collect more evidence in the form of data. All right, guys, that's it for the video. I went ahead and went over the entire problem set. I hope you find this useful, and of course, I'll see you guys in the next one.